recording, and now we get to see the technique of solving it with the inverse matrix is good, but once you get to the 3 by 3, you need your calculator, which is all right because then it makes it quick. But if we wanted to solve things without a calculator, then we need to develop another technique. And the technique that we're going to be using is called Gaussian elimination. And there's some Gauss-Jordan elimination, and there's reduced row form and reduced row echelon form of matrices. So, this is a pretty hard system of equations to solve. Yeah, there's a wonderful strategy there. And if you knew that y was equal to 2, just by sheer luck it seems, you could then plug that 2 back into the first equation, right? And solve for x and get x equals -1. So those two lines intersect at the point -1, 2. If we wrote this as an augmented matrix, so an augmented matrix puts your coefficient matrix and your solution matrix together, separate them with a straight line there, sort of where your equal sign is, we notice that we got a 0 in the bottom left-hand corner. And if you have a 0 in the bottom left-hand corner, it's pretty easy to solve because you know that y is equal to 2, and then you could substitute back in. This is Gaussian elimination. Our job is to try to get a 0 in that bottom corner. And when you have a 0 in the bottom corner, that's called row echelon form. Your calculator has that built into it as well. So we can take any matrix or any augmented matrix that we start with and reduce it to row echelon form. And it's basically a higher form of elimination. So your technique of solving systems of equations using elimination is almost identical to this. You just have to keep things in matrices, and it keeps it a little bit more organized. So we create our augmented matrix, and then we're going to use row reducing operations until we get 0 in the bottom left corner. And these are the operations that you're allowed to do, right? If you want to, each row represents an equation. You can switch 2 rows. It's just like saying, oh, I want to write this equation first and this one second. That is perfectly allowed. But sometimes there's strategy to that might be helpful to do, okay? You can multiply any row by a constant, as long as it's not 0. Multiplying by 0 will make it all zeros, and it's not, you know, although it's nice to know that 0 is equal to 0, it doesn't help us. But the biggest thing that we're going to do is we can add a multiple of one row to another. And by add, it also means subtract if you want to, because a multiple could be a -1, and then you could subtract. So you could add or subtract multiples of one row to another. Okay? Once you get that 0 in that bottom corner, then you'll have one solution, and you'll be able to work backwards to find other solutions. Whoa, I've got the answers here. Let's erase them. There it's gone. Apparently, 1 and 12 is apparently the answer. So what we have here is 1, -2, 10, 1, 4, and 16. Hello. Oh, and we got our test back earlier. If you want to have a look over it. My notation that I'm going to use is I want this row to have a 0 in the bottom left. So I'm going to take row 2 and change it by doing row 1 minus row 2. So this is what I'll write above my arrow. What's changing is row 2. Okay? So I can rewrite row 1 because I'm not changing row 1 at all. It's still 1, negative 2, and 10. But if row 2 is now becoming row 1 minus row 2, 1 minus 1, that would give me 0 here. Negative 2 minus 4 will give me negative 6. And 10 minus 16, negative 6. Once we get that 0, this now means that negative 6y is equal to negative 6, and y is equal to 1. We also know that x minus 2y is equal to 10 from the first equation. And now that we know that y is 1, we can get x is equal to 12. So our solution is 12, 1. Yes, to look ahead of time at the answer. Let's see, did I keep the answer for the next one? Getting my eraser ready just in case. Okay, so, yeah, didn't know this would be so. So again, we can set up our augmented matrix 2, negative 3, negative 2, 4, 1, and 24. Hello. So there's our matrix. I want to get a 0 here. I can do that, so I want to change row 2. Can you see that if you took row 2 and minused 2 of row 1, that would get you a 0. Again, I'm not changing row 1, so I can rewrite it 2, negative 3, negative 2. But if I take row 2 and subtract 2 of row 1, and this is where matrices will cause you problems, because you're not doing hard math. You're actually doing pretty simple math, almost simple enough that you can say, hey, I wonder about something else at the same time. Just enough to make an easy mental math error. So you have to, in each of these steps, take your time. So I'm taking row 2, 4 minus 2 row 1s. That'll be 0. 1 minus 2 times negative 3 will be 1 minus a negative 6. 7. Can you see yourself writing negative 5 there? Quite easily done. And now, 24 minus a negative 4 will be 24 plus 4, 28. So this tells us 7y equals 28, and y is equal to 4. And this one tells us that 2x minus 3y is equal to negative 2. So 2x minus 3 times 4 equals negative 2. 2x equals 10. X equals 5. So our solution is 5, 4. Right, from the eraser section. Yeah, I'm waiting. I'm just getting ready. I'm going to be strategic this time. Yeah, you got it? Okay. I know, but this is... Okay. Ah! I was trying to remember exactly where the answer was last time, thinking that the answer would be in a similar spot this time. I guess, yeah. Yeah, I could skip this question last time because the class was stronger than you guys. Anyways. What makes this one a little bit different? Right? Yeah, the format's a little bit. So I'm going to change this. It could be minus 3x plus y equals negative 2. And x plus y equals negative 6. Negative 3, 1, negative 2. 1, 1, negative 6. I want the 0 here in the bottom left. Can you see that you could get a 0 in the bottom left if you went with fractions? Okay? I don't know if I necessarily want to go to fractions. Okay? Or, so sometimes it might be in this situation that I'm going to take row 1 and interchange it with row 2. That's not wrong. And some of you might say, if you already like something better to begin with, why not just write it that way to start with? There's no reason that I had to write equation 1 on the top and equation 2 on the bottom. I could have done it otherwise. But if you don't like the order of something, this is one of our operations. You can switch the order. No. You could have done something to make it work. Right now, I'm going to change my row 2 to be row 2 plus 3 row 1s. Yeah, there's many different options. It is. Again, the goal is to get a 0 here, bottom left-hand corner. Okay? So if I do row 2 plus 3 row 1s, this will be 1 plus 3, that will become 4, and this will be negative 2 plus negative 18, negative 20. Once we have that 0, this tells us that 4 y's are equal to negative 20, so y is equal to negative 5. And we know that x plus y equals 6, so x plus a negative 5 equals 6. And so x is equal to 11. And our solution is at 11, negative 5. Did you find your mistake? No. Okay. Yeah. Negative 18 plus negative 2. Oh, there you go. That's your mistake. That would be a good question. If I wrote it wrong to begin with, that would be very sad. Oh! No, look at it was good there. And then it just disappeared there. Yeah. So this will be negative 6, and then negative 1. There is yes. And this is what will drive you crazy with matrices. Okay? One little lapse of focus, because there's oftentimes, like, what was I doing in row 1 here? Nothing. So I wasn't even thinking about row 1, because all I had to do was copy it down. And copying something down, apparently, you decide is the easiest thing in the world. So should I be thinking about what I want to do next? Yes. And what happens then? You make a small mistake with a negative.
Is it good practice to verify your answers in the equations that you were given?
Yes, and you should also, so whatever answer I got, I would plug it in. Okay? If that answer didn't work, okay, then you can look for your error. Looking for your error is a very frustrating endeavor in matrices. Okay? I would recommend, if you decide to look for your error, number 1, get the right answer. Once, like from the answer key or from your calculator, and plug the answers like here. I can check. Does negative 1 minus 5 equal negative 6? Yes. Before, it didn't work. If you're working on the questions out of the handouts, the answers are on them. Okay? If you're having a strategy for finding errors on a test that you don't have a calculator, if it doesn't work, I would say usually it is quicker to start the question again and go at half speed and really make sure that you make no mistakes than it is to find your mistake. Okay? Finding your mistake, sometimes you can get lucky. Okay? But often you just look over it and look over it and look over it and say, can't find anything wrong. Then I would recommend starting it again. And the nice thing about starting it again is that it gives you something to do with results. You've ever been driving and you're sort of in a traffic jam? And you can either stay in the traffic jam or take a longer detour. Somehow, taking the longer detour just because you're moving, even if you get through it exactly at the same time, feels more worthwhile than just sitting there and slowly moving forward. And so that's why I'd recommend start the question again, do it slower, and make sure you don't make mistakes along the way. Question. Do I have to write the x's first? Okay. If I solved this. Is it not the same thing as this? Well, it's not quite this, well. What do you have to remember? If you use the first one, you'd have to remember these are y's and these are x's. If you use this one, you have to know these are x's and these are y's. Okay? So generally, we like to do x's, y's, and answers just because it's alphabetical and it gives us a system that we always do it. I also like doing this way because can you see that you can easily make row 2 plus row 1, and you get that 0 right away. Add them, add them, add them. And so you would get 4y equals 20, y is equal to 5, negative 2x plus 3y equals 11, negative 2x equals negative 4, x is equal to 2. And we get 2 comma 5. Again, can you plug it in? Is 15 minus 4 11? Yes. Is 5 plus 4 9? Yes. So it is a good strategy once you're done to plug things in to check. And that is Gaussian elimination. Yes. Whew. We're going to pause this one, start a new video.